Okay. I think that's the last thing you have to know is how we plot all the data scatter plot on the TI calculator. Okay. For this worksheet, there's 3 examples on the top, and there's one more example on the bottom. I'm going to show one of these on the top, and I'm showing you this one. Okay, now you can practice the rest part. For the first one, if some data are given, okay, and we only know when x is 22, y is 7, 18. We don't know anything between 22 and 12. So sometimes if the randomly data are given, how are we going to plot those data to your calculator? Okay, so first step, let's go to stats and click enter, and then you are able to see this page. Okay. And all the first column, I put the x values here, and then second column, I put the y value here. Okay. Now I want to graph, so you have to go to second y equal to, and turn on your scatter plot options. So click enter and turn this on. There's some options. You can choose different type of the graph, but it doesn't matter. Just to make sure your x value goes with L1, y value goes with L2. And now let's graph. Okay, you will get this one. Or sometimes you might not have a data. For example, if I do this way, after I graph, I didn't see anything here. Okay, so there's a 2 way. First, by using those values to change the window by yourself, the smallest x will be your x minimum. The maximum x will be your x maximum. And then you're able to see your graph. Or second way, calculator will do that for you. You just go to zoom and then go all the way down, number 9, and the zoom stat. Click enter. And then you're able to see all the data. Okay? And then look at all this data. You're also able to find equations and find a function, make it fit those data really well. And by using that equation to predict all the different y value at maybe here, here, here. Okay. So how we find that equation? There's multiple different type of the equations. You need to look at your graph, your data, to see what type of the equation you need to use. For this one, it looks like linear equation. So that's what I'm going to use for linear. And if your data look like this way, that will be quadratic. If your graph look like this way, that will be your exponential. Okay, depending on what data you have, then you will pick different equation. Okay, how we find that equation will fit those data? We go to stats again, and then go to calculus, and go all the way down to find the equation I want. I said we want a linear, so that will be linear, and the phi will be quadratic, and that's a cubic, and then you have an exponential. After that, you can just find it later depending on what data you have. So now I just click number 4, linear. Okay, when I click enter, the calculator will ask me my x value is L1, yes. My y value is L2, yes. And then if I do nothing for this part, I just enter. And then that's the equation the calculator gave to me. AX plus B, and my A is equal to this number. B equal to this number. So you can write down your equation on your paper and go to y equal to, and type your equations here and graph the equation. Okay, but that's too much. There's an easy way is we still go to stats and calculus, and we find a linear. Click enter. This time, I need to do something over here. I want to save my equations to somewhere on the calculator. Okay, where I want to save to? We have a y1, y2, y3, y4 when you're trying to graph. So now I want to save to y1. How I type y1 here? You just need to go to alpha and trace. Okay, let's pick y1. So enter. And now enter. After I have these equations, now let's go to y equal to. my equation already be there. Okay, you don't need to do any change. So now let's graph. So we will graph the equation at the window at the same time. And you can see that more obviously those data will fit the line really well, but those data are not fit really well. But that's the best line we're able to find. The calculator tells us this equation will fit all those data at the most options. That's the best option, okay? And now I want to see how the y values are different. Compare the actual value from the table and the predicted equations we have from here. So I go to Stats, Enter. We go to this page again. That's an X, that's a Y value from a data. Now I want to put the Y value from equations here, so that makes me more easily to compare how those Y values are different or how close they are. So that means I need to type my equations over here. Also, we already saved our equations earlier, so we just need to find out that. So go to L3, click Enter, and now let's put our equations here. We go to Vars, and go to Stats, and Enter. Go to Equation, and the regular equations, okay. See, the equations here now. But you have to change in something. What you have to change? Look at this equation. We have an x here, but there's no x from the table. The calculator will not recognize your equation at all. So you have to change your x to what value you're using from this table. And I just said earlier, my x is L1. So I just change this x to L1. How I find L1 on the calculator? It's down here. So it will be second, and the number 1. You can see my x changed to L1 now, and the Enter. See, I have all the data at the 1 second. Okay. Now you can compare these two y values. That's the actual data. That's the predicted functions. We're trying to model our data. You can see this one is not close, but some of the values are really close. Like these two are really close to each other. Okay, and that's how we find the equations and how we find the y values, how we graph the data and the equation at the same time. Okay, and you also can do number 2 and the number 3 by yourself. But make sure after you graph the data, your equation might not be linear anymore. Might be quadratic, might be exponent. You have to decide, but look at your data on the calculator. Okay, that's how we do this one. And then look at the last one, number 4 on the bottom. For this one, same thing. All the data are given. That's the x value represented by time, and that's the y value represented by temperature. And so first step, I want to graph all this data on my calculator. Okay, so I might need to delete all this. Clear, Enter, clear, Enter, clear, Enter. Okay, let's restart to typing. X. Okay, after done, let's graph. So go to second, y equal to, make sure our scatter plot options is open. Okay, it's on, and then graph. Oh, I forgot to delete my equations. Okay, let's go back. Clear this, and now let's graph. There's nothing here. So remember, we can change the window, and the calculator can do that for you. So go to Zoom, and then go to number 9, Zoom Stat, and Enter. See, the points come out. And our data will be look like this one, and this one. And you can go to stats and the calculus to find what type of the equation you want to use to find what's exactly that predicted equation is. But this question has a little bit different because the equation is a given. The problem already gave you these models. You need to do is go to y equal 2 and just type this equation in to graph it. So 0.026 x cubed minus 1.03 x squared. Oops. And plus 10.2x plus 34. Okay, now let's graph. Do you think this equation fit this data really well? Yes, of course, they fit really well. And that's how you answer the part A. You can see by the graph, they are almost exactly same. Okay, and then for part C, find when was the temperature increasing and decreasing. Now we can look at the graph. The graph is increasing from here until this point, and decreasing and then increasing again. So I need to find out what this highest point is and what this lowest point is. We're now using data this time because data is only at specific time. It's not for all the time. So we have to using this equation right now. So we go to second trace and find the maximum values and left bound. So let's go to the left side of this highest point and enter, and move to the right side of this highest point, enter, and enter. This number will be 6.6. So my increasing interval will be from 0 to 6.6. And you can see we have another part. It's from this number to that number. Okay, let's find out what that number is. And the second trace, this time we're going to pick a minimum because that's on the lowest point. So let's move to left side of this lowest point, enter. And move to the right side and enter, enter. So that will be the x value. So it will be from 19.8 until 24 because that's what this question gave to you. That's how you find the increasing interval. And now decreasing. Decreasing will be from this point to this point. And we already solved that, so it will be 6.6 to 19.8. That's how you find the increasing, decreasing. And then look at D. Approximate the maximum value of minimum temperature. Okay, look at the maximum. The maximum value, no, let's talk about minimum first. The minimum value is this lowest point. So the x value will be the time. This y value will be your minimum temperature. So I just write down 19.8 as my x and 33.98 as my y values. And this number going to be the minimum temperature. Okay, same thing. For the maximum value, like what we did earlier for this point, you're also able to see what that y value is. And that will be your maximum temperature. Okay. And the last one, could we use a model to predict temperature in the city during the next 24 hours? No, we cannot because this model only works between 0 and 24 because that's what we can find out by follow those data between 0 and 24. We don't know what's going on with after 24 hours. There's no hint, there's no information about that. That's why we're only able to use this equation to predict the temperature between 0 and 24 hours. So now let's find out what's a predicted temperature we can find from this equation. So we already have these equations here, and you only need to go to graph. No, not graph, the table, second graph. Okay, you're able to have all these y values here. So you just write down when x is 0, let's go find 0. When x is 0, y is 34. And when x is 2, y is 50.488. And when x is 4, y value is 59.984. And when x is 6, y value is 63.736. And you can keep going. After you've done that, you can compare those y values and those y values. You can see they are really close to each other. That's why we can tell this model fits those graph really well. This model fits those data really well. And that's how we do the scatter plot on the TR calculator. And this will be on the Unit 3 Test 2 also. So make sure you know how to do this by using calculator. And if you have any question, let me know.